The advanced question says, if there is no seasonal effect on human births, we would expect equal numbers of children to be born in each season, winter, spring, summer, and fall. A student takes a census of her statistics class and finds that of the 120 students in the class, 25 were born in winter, 35 in spring, 32 in summer, and 28 in fall. She wonders if the excess in the spring is an indication that births are not uniform throughout the year. Part A says, what are the null and alternative hypotheses associated with this question? The null hypothesis is that there is no seasonal effect on human births. The alternative hypothesis is that there is a seasonal effect on human births. Part B says to compute the chi-square statistic. To compute the chi-square statistic, we plug the observed values of 25, 35, 32, and 28 into L1 in our calculator, and the expected values of 30, 30, 30, and 30, respectively, into L2. We put the number 30 into the column of expected values because 30 is 1/4 of 120. We will use an alpha of 0.05. Then in the calculator, we find chi-squared goodness of fit test under stat tests and use a DF of 3. We get a chi-squared value of 1.9333 and a p-value of 0.5864. Part C says, how many degrees of freedom does the chi-squared have? The chi-squared has a DF of 3. There are 4 seasons, so n equals 4, and the degrees of freedom is n minus 1, and 4 minus 1 equals 3. Part D says, what do you conclude about the null hypothesis at an alpha of 0.05? We failed to reject the null hypothesis that there is no seasonal effect on human births because our p-value of 0.5864 is larger than our alpha of 0.05 and any other reasonable alpha.